Okay, Assalamualaikum and selamat sejahtera. So, today we will be talking about component and deployment diagrams. So, actually I've uploaded a few videos as well, additional videos so you can see. But also I had a request saying that it's still not clear how to do a component diagram. So actually a component diagram seems that ada lots of versions out there. So but I like to keep it simple, short and sweet and simple. So I will actually show you how to do a component diagram for your assignment, especially your project, right? And we will try and keep it simple and understandable, can be understood by most people, right? Okay, so basically what you're going to learn today, we want to understand the purpose of component and deployment diagrams. What does it represent, when do we use it, okay? Then we want to know what are the notations, the symbols that you're supposed to use in your component and deployment diagrams. Then you want to know how to draw the component and deployment diagrams. Right. So what's a component actually? So a component is actually represents like a specific physical file, maybe like a .java file, .exe file, right? Can represent modules, right? Interfaces. So it's a group of classes. Okay, so it's not one class. You have your class diagram, right? So a component is actually a group of classes, right? So it's a higher level of class diagram is more detailed. This component is a bit higher level, right? So what are the notations for a component diagram? So we have a package, okay? So this is a UML1 notation, but now we have UML2. It's a little bit more complicated notation, but actually I still accept this UML1 notation for the sake of keeping it simple, right? Because you have a lot of diagrams to draw and it's quite challenging doing it online, studying online, right? So I hope this will help you, go through your project much easily. Okay, so we have a package. So package is actually a group of components, right? So it's much a component is a group of classes, package is a group of components, right? So then we have this interface. So interface is actually a collection of operations that specify a service, right? So it's just telling you what the component is doing. So a component has a name, maybe a file name or exe file or .java file or library, right? So this interface tells you, what is the purpose of that component, right? Then you have an association relationship, okay? Then we have a dependency and a realization relationship. Right. So alright, so this is an example of a component diagram. So for this component diagram, we're just using the dependency relationship. So what component depends on each other? So for me, it's enough if you just use the dependency relationship, right? So component 2 depends on component 1, component 4 depends on component 1. So for your assignment, you don't have to use all the other notations if you don't want to, right? But you can, no problem, right? Okay. So For component diagrams, a name is required for each component. So if you use put a component, you make sure you have a name. Okay. So it's basically what is the physical file name. Like for example, for a registration system, so you have, and you're using C++, for example. So it can be a registration manager.cpp.c++ file. Okay. Then you have a registration form. Your registration form can be a HTML file, maybe, right? And then we have a course header file, right? And then your course C++ file, because your header file is usually linked to your main C++ file, right? So it's dependent on the header file first before it depends on the C++ file, right? So this is an example, right? Okay, so then we talk about packages. Okay, so we know packages is you group a few components, right? So example, so you have a interface, a registration user interface. So you have a few, so you put that as a package, right? Because your interface consists of, a few components, a few files, HTML files or PHP files, right? Then you have the GUI widget. So this GUI widget may be your CSS, your Bootstrap, or your JavaScript, something that you use to help to enhance your user interface. Okay. Then there's your registration system, right? So this is your software, right? But so you're grouping all your software modules into just one package called registration system. So this is one example how you can do it. Another way is you can specify what are in your packages, right? So this one, we're using the boundary control entity pattern, right? So boundary would be your interfaces, controller would be your controller, the one that interacts with your interface and your entities or database, right? So boundary is your interface, controller is the middleman or the middle person. Entities usually represents your database, your storage, right? So this is another way, right? You can actually do it. So this one is also using just the dependency relationship. Okay, simple, right? Right. Okay, so this is another way as well. So this is you using a component diagram to represent a process, right? So your process can be maybe a registration process, a course selection process, whatever process that you compile to an exe file. So you have your C++ file and your header files in there, right? So you have the dependencies. So your exe files, your executable files depends on your header files and your also main files, your C++ files. If you're using C++, if you're using Java, then Java. Just specify what is the name of the physical file. Okay, so this is another way you can do it as well, right? So rather than just drawing using the component, you specify your HTML file and your library files as well, right? So this is also a simple way. It looks a bit more complicated. So like I said, your executable file can represent processes such as curriculum, process of creation and maintaining the curriculum, or process of registration, or things like that. Okay, so basically a component diagram, it models the structure and the dependencies of components in an implemented system. So it talks about what are the pieces that make up the software, right, or make up the system, what are the physical files, right? So you may have like class diagrams, just you name a few major classes. Yeah, so one file.java file may have a few class diagrams in there, right? Okay, so it's a component diagram is a higher level of abstraction. What it means that it consists of a group of classes, right? So your class diagram is more detailed level of modeling, right? So they are building blocks, so a component can encompass a large portion of a system. All right. So we go to a deployment diagram. So what's a deployment diagram? So basically, deployment diagram, it has hardware and your connections in it. So your component diagram, it just says which files are dependent on what files, but deployment diagram it shows what is it, how is it you're going to deploy it to your client. Okay. So what is the general view of the deployment, right? Which can also overlap with your software architecture. I also have another lecture about software architecture. And if you also notice in your SDD template, software design document template that I gave, it didn't mention about software. It didn't ask you to do a deployment diagram, right? It just asked you to do a software architecture diagram, because I see that deployment diagram, software architecture diagram, it's sort of overlapping. So I think just doing one is okay, but for the sake of UML, I have to teach you what is a deployment diagram, so you know what it is. Right, so what does the deployment diagram consist of? So first, it has a node. Okay, so node is a physical element, right? So it can be like a server or a client desktop, right? Or campuses, right? So basically, deployment diagram looks like a cube. It's a very boring diagram. The notation quite boring, like just the cube, right? So, and it has connections, right? So a connection represents a physical connection, can be connecting two physical nodes, right? So a server is something physical, kiosk something physical, right? Or a console, right? So that's it. Your deployment diagram has a node and it has connections. So this is an example, right? So you have your client PCs, desktop PCs, and you have a server, right? So your server has to go through your local area network to actually access your cost catalog in your billing system. So in this deployment diagram, is saying that your cost catalog and your billing system is the legacy software. It means that it's a very old software. It has been phased out. Orang dah tak pakai lagi dah. But since there's a data still in there, so you still need to keep the software just to access the data, right? So that's why that system is in a, you have to go through the local area network to access it. It's not part of the registration server. It's a different server altogether. So this is an example of a deployment diagram, also simple. Okay, so and you can also specify your components in your deployment diagram if you want to, right? So as you can see, inside the node we have a component in it. Okay, so this is an example of a class diagram, component diagram, and a deployment diagram. Like I said, a component diagram is a higher level than your class diagram. So as you can see in here, the account class has actually been simplified to just just that, right? And you have your transactions here, right, representing this, a transaction component, right? And your card and your ATM is represented by this GUI here. So your component diagram is a group representing a group of classes. Okay, then we also have your deployment diagram, right? So right, so that's it basically. Thank you very much. Right, so I hope you can draw your component deployment diagram after this. So I try to keep it simple for you as possible, right? All right, bye.